AP Calculus AB, Unit 7, Day 4 lesson. So this will include the only kind of new thing that wasn't optimization around the final. Now, this is an idea that we talked about earlier last semester when we were doing some like average velocity and things like that. But we will officially cover it now for all applications. So MVT, initials for mean value theorem, and this one's for derivatives. And mean value theorem, mean is average. So we're trying to find the average derivative. There are some requirements to be able to use this idea. The function needs to be continuous, so no holes, jumps, vertical asymptotes on a closed interval, and differentiable on the open interval. Differentiable meaning it needs to be smooth to apply this idea. If those things are true, the average slope of the function will simply be FB over FB minus FA over B minus A. It's just going to be the rise over run between the endpoints of the interval. And that will give you F prime average. It's a really simple idea. It's kind of cool. I'll show it to you some more. There's another also conclusion to it that says there must also exist at least one point between the endpoints, between them, where the actual derivative, the actual slope of the curve, equals the average slope of the curve. Okay. So again, up here, this average slope is the slope of a secant line connecting the endpoints. Okay, and there's going to be at least one actual slope that equals the average slope. Now, let's see. We'll go into the situations where it doesn't apply in a second, but just to sort of tie this to motion, which is when we first started talking about this idea. So you're taking a trip to Santa Barbara on the 101, you go over the San Marcos Pass, you have varying speeds, windy road. Let's say it takes you 1.5 hours and the distance is about 90 miles. And so this is distance versus time. And so this is the point you're going to end, and this is the point you begin. Now, this is distance, which means everything's positive. It's different than position, where yeah. So, a more realistic graph would be you got to start at a zero slope, you got to end at a zero slope. And, just as, just to show you, I don't know, just something interesting, something like that. Maybe this is the sort of the distance or position versus time. We start at AFA, just generically, and we end at BFB, generically, where F is the distance. Now, along this curve, you have lots and lots and lots of different slopes. In fact, there's infinitely many slopes. And these slopes, these tangent lines of these slopes, are your speed, your velocity at any of those points. And so there's infinitely many of them. And I want to find the average of all those. Our trip took 1.5 hours and we traveled 90 miles. The velocity or the speed, absolute value of velocity, is going to equal the slope of the distance versus time graph. So more specifically, the speed, if we're talking about distance, velocity would be position. The average, your average speed. Now, if I asked you, I feel like a lot of you guys can answer this question without high-level math. If I said, all right, what was your average speed if it took you 1.5 hours to go 90 miles? Like, how can we figure out your average speed, your average miles per hour, hint, miles per hour? You would say, well, how far did I travel? How long did it take me? If I divide that, that would give me 60 miles per hour as my average speed. right? I mean, that's, if you want to find the average of how long it took you to do something, you take how much you did divided by the time, and that gives you your average rate. What that is, if you look at our graph, that's the total rise over the total run between the endpoints, right? That would be the average slope. The average derivative is just going to be f of b minus f of a over b minus a. It's just going to be the slope of a secant line connecting the endpoints. It's just going to be rise over run. And in this case, it'd be 90 minus 0 over 1.5 minus 0, and you get 60. You get the same answer. That is correct. The logic of that is correct. So it's really that simple. So it doesn't matter how curvy or crazy this graph is, no matter how varied your speed was, your average speed is still the same. So that's kind of crazy. It's as simple as that. Now, did you ever go 60 miles an hour? Like at least one time? And if you look at the picture, that would be when the slope of a tangent line was the same as this slope, right? So you could see one here, you could see one here, you could see one here, you could see another one here. So I'd say 4 times based off this graph. But the answer is yes, at least once, for sure. At least once. Maybe more, right? I'd say 4 times in this picture. That's the second part that says the actual slope will have to equal the average slope at least one time. Okay? But it's got to be continuous and differentiable. Let me show you an example where some of those things don't make sense. So even for a graph that's continuous, like it makes sense, hopefully, that's got to be continuous. Because if you have a jump, how do you deal with that with slopes? There's going to be an infinite slope right there, and that just doesn't make sense, right? So it's got to be continuous for sure. But it's also got to be differentiable, because let's say this is our graph from here to here, and then it goes like this, right? It's continuous. It has infinite number of slopes. It has an undefined slope here, which is probably, which is an issue. If you're to connect the secant line, this slope right here is your average slope of all these slopes, not including the undefined one. But nowhere on this graph did it actually have a slope that was equal to this, because it's not differentiable, right? So can't have any corners or cusps or vertical tangents or undefined corners, So that is a requirement. Now let's do some problems that are a little less application, That's kind of like what we did before. We found average speed last semester. But let's just do some that don't really have any, words to them. Find all the values of C as guaranteed by the mean value theorem. That's this right here. This is the values of C as guaranteed by the mean value theorem. Now you got to watch out. C has to be between A and B. It's an open interval, because the endpoints, remember, we usually don't talk about derivatives at the edges because derivatives are two-sided issues. So if we're not considering beyond those edges, then we can't consider derivatives at the edges. So it's got to be between the endpoints. And that could happen more than once. It can be more than one C value, and you're going to be required to find all of them. So here's a function that we want to find all the C values as guaranteed by the mean value theorem between -1 and 5. Now, we need to check to make sure we're even allowed to use mean value theorem. Is this a continuous function on the closed interval? Yep. Is it a differentiable function on the open interval, -1 to 5? Yeah, it's a cubic. Polynomials are differentiable. So just make sure. So even though they didn't ask for it, they didn't ask for the average derivative, but you need to find the average derivative first in order to find this special place where the actual derivative equals the average derivative. Now I could draw a sketch of this graph, by the way. Like if I were to sketch it, I'd be like, oh, well, let's factor the x squared out. And this is x equals 3 is the x-intercept, x equals 0 is the x-intercept, and it's a double there. And 3, you don't need to sketch it usually, but maybe at first this just might be good practice. And if you plug -1 in, you get -1 minus 3 is -4, right? And so the graph kind of goes like this. And we go all the way to 5. Plug 5 in, it's 125 minus 75 is 50. So the point up here is going to be at 50. And we want to know the average slope of all these slopes. And it's really just going to be the slope of a secant line connecting them. And then the second part is the guarantee. Well, I think we'll get one here, and we'll probably get one here. I think we'll get 2 answers between -1 and 5. If you get other answers outside of them, that just doesn't make sense, and we'll throw those out. So the first thing you want to do is find f prime average. Label your work by f prime average. Why don't we show the setup? F of 5 minus f of -1 over 5 minus -1. Okay? Then you can calculate values. We plug 5 in here, it's 125 minus 75 is 50. Plug -1 in, it's -1 minus 3 is -4. 5 minus -1, show your work. 54 over 6 equals 9. So this is your f prime average. They didn't ask you for it, but you got to find it. It's got to be clear in your work. So then we're going to take the actual derivative. Well, the actual derivative, we just use our derivative rules. 3x squared minus 6x. Power rule, right? And now we want to set them equal to each other. F prime average to f prime x. So it's going to be 9 equals 3x squared minus 6x. So now you got to solve the algebra equation. Move everything on one side. It's polynomial. GCF is always a good idea to take out first. And, hopefully we can factor this. Let's see if we can. We're going to use quadratic formula. X minus 3, x plus 1. So x equals 3 and x equals -1. Okay? Now, my sketch was really rough. Okay? So, it might not have been perfect. We did get 2 answers. The problem is that one of them is on the endpoint, the edge of the region we're considering. So we don't include it in our answer. Okay? Shows up in your work. Final answer is just going to be C equals 3. C is just that letter they use for the x coordinate where this special thing happens. So we're only going to do 3. So my picture probably wasn't totally great. It probably should have been super steeper because I didn't draw it very accurately to scale. So that's what we do. Now the next graph, is it continuous? Where it exists, this has a domain issue, right? It says a domain. The inside has to be positive. So that means x has to be greater than -1. So at -1 and to the left -1, the function isn't continuous because it doesn't exist. That's important. But is it continuous where we are looking? Yes. Is it differentiable where we're looking? Yes, because it has an issue where it doesn't exist. There's no derivative. But also at -1, I'm telling you right now, you get a vertical tangent. So it's differentiable on this interval, And we'll see that in a second. Now, what does this sketch look like? Well, this is a square root function, which is like a sideways, the top half of a sideways parabola. And the +1 moves it to the left one. So this is what the graph looks like. And we're interested in 0 to 8. So, whatever this coordinate is to whatever this coordinate is, that's the slope of the secant line. And you can tell that there should probably be at least one tangent with the actual slope. But everything's cool between 0 and 8. There's issues, but outside 0 and 8, it's fine. So we got to calculate f prime average first. And set it up. F of 8 minus f of 0. This can get you points on AP test for free response question, just setting it up. Because a lot of times you guys are make silly mistakes. This tells the person you know the calculus. If you just start throwing numbers in there and they're wrong, weirdly, for some simple reason, you're not getting partial credit. Same thing for me. You plug 8 in, it's going to be 3. You plug 0 in, that's going to be 1. So we get 1/4 for f prime average. Label your work. I should know that that's f prime average. Okay, what's the actual derivative? Well, for the actual derivative, I'm going to rewrite the function real quick like this. It's a power rule. So 1/2 x plus 1 to the negative 1/2. There's a chain, but the derivative of what's inside is just 1. So your derivative is 1 over the square root of x plus 1, which tells you that when x equals negative 1, it blows up and it has a vertical tangent. Right there, right here has a vertical tangent, which would be a problem for us. But if it was in the middle of what we were trying to do this. So we're going to set f prime average equal to f prime. So 1 over 2 square root of x plus 1 equals 1/4. And we're going to solve it. A trick I like to use is I like to flip both sides upside down to get the, and then we can divide both sides by 2. And then we can square both sides. And then we can solve and we get 3. And is this between the endpoints? Yeah. So that's your C value. Okay. So that's how we do it. That's f prime average. I'm going to throw a couple other ideas at you. I think the next one we haven't really talked about either. IVT, intermediate value theorem. So in intermediate value theorem, sounds kind of complicated. What it says if f of x is continuous, it doesn't have to be differentiable. If f of x is continuous on a closed interval, then f of x must pass through all the values between the absolute max and min of the function. Okay? And more specifically, it has to pass through all the values between f of a and f of b. If the graph is connected, can it skip any values on its way from f of a to f of b? No. You have to get through every single one, right? Now, just to try and tie it to some other kind of real life example that's continuous. We all had to go to middle school. You had to go to middle school from elementary to high school. I guess that's not true for some people. Maybe this one's more true. When you were born, let's say you weigh 5 pounds. Now you're 150 pounds. Well, the only way that can happen is that you had to weigh 100 pounds at least one time. Now, maybe more than once. Maybe you went over 100, under 100, whatever, but at least once, right? There's no way you skipped it, right? So, if there's some value that you're looking for, there has to at least be one time, maybe even more. If we did this one, that value happens 3 times. And we call these C values, kind of like the last example. Sometimes they call those C values. I'll show you an example. Okay, so if f of x is continuous and f1 equals -2 and f5 equals 7, then f of x must have a 0 somewhere between. Well, 0 is between -2 and 7, so it has to happen between x equals 1 and x equals 5 for sure, right? So, just to illustrate this, if you had a graph, 1, -2, 5, 7, right? Like that 1, -2 is on the graph and 5, 7 is on the graph, and it's continuous, they're going to tell you, then, somehow it's got to eventually go through 0. Now, it could go through 0 a bunch of times, right? Could be more than once, right? Okay, 0, by the way, is an x-intercept, right? Or the function equals 0. Okay, so it's actually a really simple idea. Like, hey, you got to go through all the points. It has a really fancy name, intermediate value theorem. Extreme value theorem. We've been using this a lot, so I'm just throwing this on here one more time. F of x has to be continuous, not differentiable on a closed interval. It's got to have endpoints. There must be an absolute max and min, you're guaranteed, and that must happen at either the endpoints or the critical points. So we've been using this a lot. So here's a couple more examples of this. Find the absolute maximum of this function. Here's the function. Here's the endpoint. So this is, I mean, we were using this on optimization. This is kind of nicer because they're just giving you the function. You have to come up with it. You don't have to draw a picture. They're just giving you the points. You don't have to figure those out. So we jump into, let's take the derivative, 3x squared minus 6x equals 0 undefined. And then we're going to factor out 3x. And those are our critical points. We have our endpoints, so we can jump into a table. Still going to make tables. If you don't make a table, I'm not giving you credit. And we're going to put -1, 0, 2, and 5 endpoints and critical points. Now, if you get critical points that are outside the endpoints, you don't have to put them in your table. So you plug -1 in, you're going to get -1 minus 3 equals -4. If you plug 0 in, it's going to be 0 minus 0 is 0. If you plug 2 in, it's going to be 8 minus 12 is -4. If you plug 5 in, it's going to be 125 minus 75 is 50. Here's your max. Here's your min. There's a tie for the min. There's only one min value, but it can happen at more than one spot. Now, make sure you answer the question they're asking you. The absolute max is 50 at x equals 5. I always answer absolute max mins with at least this. What is the max min value? Where does it happen? Because sometimes they ask you for where it happens. Sometimes they ask you for what it is. Now, I'm not looking for full-blown justification here, like you do on free response problems. Here's another one. Find the maximum value of this. So you got endpoints. This is a continuous function. You got to take the derivative. Try these yourself first, right? I mean, you guys should be able to do these. Try these yourself first. I'm doing the chain rule in my head and putting the 2 out in front right away, which is the way I usually want it. 0 undefined. Trig's never going to be undefined, but I just write it there the first time. If it's 0, it's going to be cosine 2x equals -1/2. Alpha equals pi over 3. Quadrants 2 and quadrants 3 is where cosine's negative. You guys should be flying through trig perfectly. Quadrant 2 would be 2 pi over 3 in radians, no degrees, 2 pi over 3. So this is going to be 2x equals 2 pi over 3 plus 2 pi k. And 2x equals 4 pi over 3 plus 2 pi k. And divide by 2. You get pi over 3 plus pi k. 2 pi over 3 plus pi k. We're only interested in 0 to pi this time, so we just want pi over 3 and 2 pi over 3 as our critical points. There's infinite critical points. We have our endpoints. We're going to make a table. We're going to plug them back into the original function. Don't plug them back in the derivative. If you're getting a bunch of zeros in the middle of this table, then you probably plug them into the derivative. The endpoints are 0. Critical points pi over 3, 2 pi over 3, pi. If I plug 0 in here, I get 0 plus sine of 0 is 0. Plug pi over 3 in, it's pi over 3 plus sine of 2 pi over 3 is root 3 over 2. 2 pi over 3 plus sine of 4 pi over 3 is root 3 over 2 negative because it's quadrant 3. Plug pi in, sine of 2 pi is 0. You get pi. Now, you got to figure out which one's biggest and smallest. And I think we could probably get away with this without a calculator. And that's what I want you to try and do. So I would say, well, pi is about 3, so let's just call that 1. Square root of 3 is between square root of 1 and 4, closer to 4, so maybe like 1.7. Divided by 2 would be like 0.85. So I'm guessing this is about 1.85. Now the only way this could be bad is if I get two values that are really close to each other. Now this one's pi over 3, which is about 1 times 2, so that's about 2 minus 0.85. So that's about 1.15. and pi is about 3.14, right? So I think that these are all clearly far enough apart that our guesses, our estimations should be fine. We're looking for the maximum, which is clearly right here at this endpoint. So the absolute max is pi at x equals pi. I want exact answers. So if you do any of this estimation, I want to see it, first of all, because I want to be convinced that you thought it through and didn't just get lucky. But I don't want it for the answers. I don't want any of these decimals for the answers. In fact, even these are really rough answers. And even if they weren't rough, I still don't want decimals on here because you're not using a calculator. So there you go. Try today's assignment. Get some more practice on these.